Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, this lesson we will discuss combinations of R objects from N objects. The number of different combinations of R objects selected from N distinct objects is given by NCR. When we use NCR to find the number of ways, the order of arrangement is unimportant. So you will see the question use the keyword like selection or choose in order to find the number of ways. And usually the question will ask you to form a team. Let's have a look at example here. A team of 2 boys and 3 girls are to be formed from 8 boys and 7 girls. Now, we have 8 different boys and we select 2 boys from the 8 boys. So the number of ways for selecting 2 boys is given by XC2. All right. At the same time, there are 7 girls and we need to form a team with 3 girls. Hence, the number of ways is given by 7C3. By using multiplication rule, we multiply this number of ways to select boys, number of ways to select girls, and we are finally getting the number of ways of selecting a team of 2 boys and 3 girls. All right, using your scientific calculator, you press 8, shift, then look for division sign, press this button, and you will see capital C appears. All right, then followed by 2 and equal sign. Then you should be able to get the number of ways of XC2 and multiply with 7C3, and the answer is 980 ways. All right, now we will look at some past year questions. Right, when we are using the NCR from past year questions, I find the question would like to ask about selecting 3 different persons or objects with restrictions, or the specific persons or objects must be included or excluded. So we are going to discuss the questions that focus on A, selecting 3 different persons or objects with restrictions. Let's see this question, October-November 2011, variant 6.2. Geoff wishes to plant 25 flowers in a flower bed. He can choose, see the keyword, from 15 different geraniums, so 15 geranium, 10 different roses, 10 roses, and 8 different lilies. He wants to have at least 11 geraniums. So this is the restrictions given. The first restriction. So I put it here, restrictions. At least 11 geranium. And also to have the same number of roses and lilies. So roses and lilies, they have same number. All right, this is the second restrictions. Now we are going to find the number of different selections. See, the keyword is asking about selections. So we are going to use NCR in order to find out the number of ways. Flowers he can make. All right. So in order to consider these restrictions, we have to consider the outcomes in different cases. So I will list down the case 1. Since the question says we need at least 11 geraniums, so I start from 11. All right. And he wants to have total of 25 flowers. So that means we want to have a selection of 25 flowers. If we have 11 geraniums, then we still need 14 flowers, and that means we need 7 roses and 7 lilies, so that we have equal numbers of roses and lily. All right, this is the case 1. So I try to list out the case 2 before I consider the number of ways. Case 2. So let's say we try to consider 12. Is it possible to have 12 geranium? It is not possible. Why? So you can see if we have 12 geranium and total we need 25 flowers, that means we still need to have 13 flowers from roses and lily. Then we will not be able to have equal number of roses and lilies. All right, that's why we couldn't have 12 geraniums, and hence I will try to get 13 geraniums, and that means we will need 12 more flowers, and hence there are 6 roses and 6 lilies. Then case 3. So that means we need to have odd number of geraniums, and now we will try 15 geraniums. And that means we still need 10 flowers, and that means 5 roses, 5 lilies. All right. At this point, we have considered all the possible cases to have this total 25 flowers. And now we are going to carry out the selections. So refer to case 1. There are 15 different geraniums, and we need to select 11 out of them. Hence, the total ways we have will be 15, C, 11. All right. As for roses, there are 10, and we need to select 7 from them. And the lily, 8, and C, 7. So we are going to find out the number of ways of these 25 flowers, where it comes from 11 geraniums, and at the same time 7 roses and 7 lilies. So to find out the total number of selections possible by using multiplication rules, we multiply them together. All right, using the calculator, we will get the number of ways to be 1310400. All right, so we will do the same for case 2 and case 3. So again, there are 15 different geranium, and we need to have a selection of 13 geranium. That means 15 C 13. And at the same time, they must have 10 different roses, and we select 6 of them. And 8 lilies, and we select 6. So using calculator, we find out the number of ways to be 617400. And the case 3, so 15, we choose all of these 15. And 10 roses, choose 5. And 8 lilies, choose 5. So the number of ways will be 14112. Okay, in order to get the total number of selections, what would we do? We will sum up the total weights from these three cases. That's why we will have 1310400, 6174000, and 14112. And hence the total weights we have would be 1941912. All right. So there is a small little tips here. So whenever we consider the number of weights, when we consider them in different cases, you sum them up. All right. But within the same case, you multiply them. Let's say, taking example of case 1, we have a ways of selection for geranium, roses, and lilies. And hence, the total ways we have, by multiplication rule, multiply them. All right. Or we can consider case 2. Then we have this, the 13 geranium and 6 roses and 6 lilies. And all right. Or case 3, that we have 15 geranium and 5 roses and 5 lilies. So can you see when I emphasize and I multiply them, or I plus them together. All right. So in general, when we find out the number of weights within the same case, we multiply the total number of weights. But if we are considering different cases, we sum them up, right? We sum up the number of weights. So n multiply or plus. All right. So that is the number of weights for question 1. Okay, now we continue to look at question 2. So this is the question from October, November 2015, variant 6.3. There are 7 Chinese, okay, 7 Chinese, 6 European, and 4 American students at an international conference. 4 of the students are to be chosen. See the keyword chosen, and then we need to choose a group of 4 students to take part in a television broadcast. Find the number of different ways the student can be chosen. See the keyword chosen. So we are going to use NCR. If at least one Chinese, so this is the restrictions. At least greater and equals to 1 Chinese, and at least 1 European, greater and equals to 1 European. Students are included, and there's no restrictions on the American, which means it's possible to have 0 American. All right. So same thing, we will try to consider the possible cases. So I will list out the case 1. So as the question says, at least 1 Chinese, at least 1 European, and we are looking for a group of 4 students. Hence, for this case, we would have 2 American. All right. Then we look at case 2. Is it okay to have 1 Chinese, 2 European, and 1 American? Yes. So this is a case of case 2, where 4 students selected and 2 European, 1 Chinese, 1 American. Okay. So we can look for the case 3. At this time, we can have 2 Chinese, 1 European, and 1 American. All right. So can you see? It's basically the number of 2 is from the American to the European to the Chinese. Or we can also look at case 4. where we would have 3 Chinese and 1 European. All right. So as we total need 4 students, that means there will be 0 American. Correct? We follow the restrictions given, at least 1 Chinese, at least 1 European, and it's okay to have 0 American. Then we also can consider 1, 3, and 0. Or do we have any more possible cases? Yes, there's one more, which is case 6 here. There are 2 Chinese, 2 European, and 0 American. All right. So these are the cases that follow the restrictions to form a team of 4. Okay, now we are going to find out the number of ways. All right, 7 Chinese, we need to select 1. 7, C1. N, see, I emphasize N. So I multiply. 6 European, select 1, 61. N, multiply, 4C2. So use calculator, the number of ways found, 252. All right, so we will do the same for the cases 2 to 6. So 7C2 and 6C1 and 4C1. 504. Case 3, 7C. All right, so you can see that I make a mistake here. Right, we're supposed to have a selections of 1 Chinese. So this is supposed to be 1. But we are expecting 2 European. So this should be 2. So if 7C1, 6C2, and 4C1. So the number of ways we found should be 420. All right. Okay, now we're looking at case 3. So this is 7C2 and 6C1 and 4C1. All right, so using calculator, the number of ways found should be 504. Okay, then we continue. Case 4, there are 7C3 ways and 6C1 ways and 4C0. Okay, so just need to be aware that if you have NC0, it's always going to be 1 way. All right, so if you don't write it down, it's fine. Okay, using calculator, finding this 7C3 multiplied with 6C1, we get 210. And multiplied with 4C1, which is 4C0, which is 1. So I'm getting number of way 210. All right. So we continue 7C1, 6C3, and 4C0 is going to be 1, so I do not write it down. And the number of ways is 140. 7C2 and 6C2. And again, 4C0 is 1. And the number of ways will be 315. All right, so we have 6 different cases and all the number of ways. Now we need to find the total selections we have. So what do? When we have different cases, we are going to sum up the number of ways. All right. So the number of ways will be 252 plus 420, 504, 210, 140, 315. And hence the answer would be 1841. Okay, so this is the answer for question 2. Right, now we have the third questions. So the third question is the questions from May June 15, variant 6.1. Okay, so please try these questions, which is similar to the questions we discussed just now. Write down your answers in the comment below. Right, the next video, we will continue with specific persons or object that must be included or excluded. See you in the next lessons. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.